Okay, we're on 3.4. So we are learning today about linear programming. Linear programming means that we are actually going to solve some real-life problems eventually that requires us to graph using system of inequalities. Okay, so the first thing we're going to do is let's look at this example. Graph the system of inequalities, constraints. Inequalities are what we call constraints. And name the vertices in the feasible region. Oh, so many new words. Okay, so we got vertices, we got feasible region, and we got constraints. Which vertex maximizes the objective function? Too many new words. So what you're gonna do now is just graph. Okay, you're gonna graph these four inequalities so that they all overlap into a region. Okay? Go ahead and graph those four. So usually you're only used to graphing two. This time you're going to go to four. When you finish graphing, please make that area that all overlap into a different color because we're going to analyze that area. But if yours is just a bunch of lines, it's hard to see. So color it differently so you can see that that is the region we want. Okay, so let's take a look. If you try to graph this one, put it in y equals mx plus b. So that's 2y less than equal to minus x plus 5. Divide everything by 2. Y is less than equal to negative 1/2 x plus 5 over 2. In this equation, let's see, that's going to be negative y less than equal to minus x plus 2. Divide everything by negative 1. Y is greater than equal to x minus 2. All right, so we graph those two. So first one starts at 5 over 2, that's 2.5. Goes down 1 over 2, down 1 over 2. Oops. Like this. And it shades down. Okay, the second one is x minus 2. So start at negative 2, goes up 1 over 1. And like this, and shades up. And then we have our two extra ones, x greater than equal to 0. That's the vertical line at 0, and shades to the right. And then y greater than equal to 0 is the horizontal line, shades up. So basically, the region that they all overlap is this one. Any questions on getting this? Okay, I have a lot of confused face. What's going on? Yeah.
I'm just shading.
The shading part. Okay, so this first one is, let me color the line. That is this line. So this one we're going to shade down. Okay, and then the second one is this one. We're going to shade up. Up means this side. So the overlap, so this one shades down, this side shades up. So basically they're overlapping right here in this, I guess, diamond region. And then because we want x to be greater than equal to 0, y to be greater than equal to 0, we end up being in this quadrilateral region. Okay, now let's identify some vocab. Okay, this area that we shaded where it fits every single constraint. Let's talk about constraint. These inequalities are called constraints. So constraints, you know, like if you put like a leash on a dog, we call that a constraint, right? So something that pulls something else in. So all of these inequalities are called constraints because it says you can only be this much or you have to be at least this much. So it's like a requirement, like a limitation. So they are all constraints. So everything that fits in that constraint is this region. This region we call feasible region. So there's a name for that, feasible region. Can you guys see my writing well? I don't know. Feasible. Feasible means you can do it, it's possible. So feasible region means this is the possible region. So this is the region where every point in there will make the constraints all work at the same time. You can pick any point in that region and then it will fit all your constraints. Yeah, your
Or the line going up, the line that's on -2.
Why is this going up?
No, shouldn't it be going down because it's a negative x?
So if you look here, if you subtract x on both sides, that's going to be a negative x plus 2. And then you have to multiply by -1 to get rid of the negative on the y. Okay. Now, the most important part. Sorry, we usually have a objective function that we had to meet. Objective function means like outside of these constraints, there's something else that we actually want. And that thing that we actually want is this. We want 2x plus y, whatever that means, 2x plus y. And we want that to be a maximum number. So you always have something outside of the constraints. That's another equation. And usually you want to maximize or you want to minimize. Aiden is like showing me this. Oh my gosh, so much stuff. You want to maximize or minimize this objective function. Now, what's going to maximize or... it's giving me a look. Okay, what's going to maximize or minimize this function? It has to do with the vertices of the feasible region. So, really, the only parts we care about are these vertices. Vertices are the corners of the feasible region. The corners of the feasible region. So in this one, there are 4 vertices. So one vertex is called vertex. Plural is called vertices. Okay, so this one has 4 vertices. Okay, let's review the vocab. First, you start with your constraints. Constraints are all your inequalities. Next, once you graph all the constraints, they will eventually all overlap into a region, whatever that region looks like. And we call that region feasible region, meaning this is the area where everything will work in my constraints. That feasible region will usually have some corner points. We call those corner points vertices. What are these corner points for? They are used to maximize or minimize the objective function. And the objective function will be given. Okay? All right, so let's look at vocab. Constraints. So this is the equations of inequality. Or inequalities. Let's skip implicit constraint for now. Feasible region is the area of the graph that satisfies all the constraints. This area, no matter what point you pick, will make all of them true. Make all of the constraints true. The objective function is, what did I put? The goal of the problem. What you're actually doing. So they want 2x plus y to be maximum or minimum. So what you're trying to maximize or minimize. Okay, vertices are going to be the corner points of the feasible region. These are usually the points you would check in the objective function. And then implicit constraint, which for you right now, it doesn't really mean anything. Tomorrow, when we actually go over real life problems, then it's going to actually matter. So implicit constraints means it's implied. Do you guys know what implied means? What does it mean? some of these words are really hard to explain. You also have to.
It's not like said.
Uh-huh.
It's right, I guess.
Like if someone says.
Like unsaid knowledge that you should know.
Yeah, so like if a girl says, "How do I look today?" and then you said, "Oh, it's fine," the implied meaning is it's okay. Kind of like that. Anyways. Okay. So we're actually going to solve this. All right. So the question is, which vertex maximizes the objective function? All right. So the first thing we need to find all the vertices. Vertices. All right. So we have 4 vertices this time. Let's start looking at each one. Okay, what is this one? This one I'm pointing right now, bottom left. 0, 0. So we just want to list them so we can analyze all of them. What about this one, this top left corner one? That's it? Not 0, 2. 0, 2.5. That was the y-intercept. Just told me. Okay, how about this one? This is the x-intercept of one of those. 2, 0. All right, this last one. Yeah, it looks like 3, 1. What if it is not actually crossing a nice grid point? Then it sucks. It does. Then you have to do what we did on the warm-up. You have to solve. Okay, so all of the ones that, look very nice, and then you're like, I can't, pretty much figure out what those points are. Yes, those are the x and y intercepts. Just, you already know what those points are. This one, when you can't figure out what that number is because they're not actually intersecting at a nice point, then you have to figure out where these 2 lines intersect. You have to do that by elimination or substitution. Okay? This one they are actually intersecting at a nice point, 3, 1. So just put 3, 1. Okay, on the other side of your table, you're putting in the objective function. The objective function for this one is 2x plus y. So the question is, which vertex is going to maximize 2x plus y? Now, how are you going to figure out what that number is? Just put in, x and y in 2x plus y. Okay, so first one, 0, 0 is a vertex. So put it in 2x plus y. You get 0. 0, 2.5 into 2x plus y. That's going to be 2.5. Okay, 2, 0 into 2x plus y. 4. 3, 1 into 2x plus y. 7. So which vertex is going to maximize? 7. Vertex.
3, 1.
3, 1. So make sure you read the question. Sometimes they will say, which vertex? You put 3, 1. Sometimes they'll say, what is the maximum value? Then you put 7. So make sure you read the question. Okay, let's see. Was there a second point? Nope, that's it. Okay, let's try another one. We usually... okay, same thing. So just practice graphing and finding the vertex. Okay, so graph it first. Let me check your feasible region before you go too far with your vertex. Okay, so I already saw 3 of you doing this wrong. Make sure you divide so 2y is greater than or equal to negative x plus 7. Divide by 2. That means everything divides by 2. I saw a few of you not dividing 7 by 2. So please be careful and just write everything out. You rather take a little longer than getting it wrong. Bless you. Okay, so that is down 1 over 2. This here. And we're going to shade up. And then x greater than or equal to 2, that's this one here. We're going to shade up, meaning higher x values. And then y equal to 0, shade up. that means the top half. So basically the overlap is this side. Okay, we have a tendency to always want to pick the area that's enclosed. So a lot of people would just automatically pick this area without thinking about, does that even make any sense? So please don't do that. Shade whatever is actually the region. So our feasible region is open. And that means we only have a few vertices. Okay, so the actual vertices are going to be here and here only. Because the other area just goes forever. Your graph is stopped because I don't have enough graph paper, but that doesn't mean the graph is actually ending there. Okay, so those are my only two vertices. Okay, let's start with this bottom one. What is this point? 7, 0, good. What is this point here, the other vertex?
2.5.
Ooh, very nice. It is 2.5. Now, if you couldn't see that it's 2.5, what can you do? Solve, right? It's basically where two lines intersect. Those two lines are x equals 2 and what was the other one? X plus 2, y equals 7. So we're just finding where those two lines intersect, and you can solve them. All right, the objective function in this case is x plus 3y, yes, and we want to figure out which one is going to minimize. So go ahead and do that. Okay, what's the value from the first vertex? 7. Okay, what's the value from the second vertex? 9.5. So which one's going to minimize? 7, 0. Yes. How do you guys feel? Okay, just part. Yes, I can see that. Okay, try another one. This one is just multiple choice. It's just multiple choice. When you say multiple choice questions, I'm going to tell you a trick. You are only looking at one answer. Only one answer is correct. You don't want to waste your time going through the entire process and then only find out that, oh, only one of them will work. So what's a fast way of finding the answer? Yes, you guys are so smart. So you don't really need to graph anything. You just need to find that answer. However you find it, the fastest way, the better. The faster, the better. Which one is going to maximize?
B.
Yes, very good. No need to solve any of those constraints, right? Yeah? Okay.
Wait, so you just plug it into the 2x plus y?
Yes. Yeah, that's all you do.
Oh, we plug it in.
Yeah, the objective function. You have a question?
Oh, yeah. Whenever you're finding the system
Mm-hmm.
for the ones with inequalities,
Mm-hmm.
we look for the last one. How do we know where the system is?
It's wherever they overlap. So on the diagonal line, if shades up, and you have x equals 2, shades to the right.
Yeah.
So that's already creating the right area. The area to the right is where they overlap. The last line is y equals 0, shade up. So that constrains everything to only the top half of the graph.
So you said that people tend to choose that little.
Yes, because it looks nice. And then people want to just choose the area that's enclosed.
So why would that one be wrong?
Because the diagonal line says shade up. This side would be shading down, and that's not what the equation says.
Oh, okay.
Okay, let's see if there's one more.